Hello and welcome to 1-3 of our geometry class, Distance and Midpoints. Let's start out and let's get right into it. Distance. Last time we talked in class, we talked about segments, line segments, and line segments have some kind of length or some kind of distance between those two endpoints. Distance will follow pretty much that same logic, except we're going to be working with number lines and the coordinate plane. So first things first, distance in terms of the number line is a one-dimensional, it's in one dimension. So we are working with the number line on a number line. So it is one-dimensional, meaning it only goes left and right, or up and down, or like through the page and away from the page. That's a little more complicated. That's a little more calculus, but let's not get into that. Let's just stick to the basics, one dimension. And let's go ahead and draw a number line while we're at it. Now, it doesn't have to be this long. The only thing I really care about is we start at 0 in the middle. Let's go -1, -2, and let's go -3 at the very least. And then we'll go 1, 2, 3, 4, 5. Okay? And I'm going to put points on a -2, which will be A, and I'll also put it on 4, which will be my point B. Now, we could absolutely say that we could have a segment here from A to B, but we're also going to be talking about that distance. So, roughly put, I guess, the distance is the absolute value of the difference between their coordinates. Of the difference between their coordinates. Now, you could always just count, which is kind of the nice part about this example. And you could literally just see, okay, we go 1, 2, 3, 4, 5, 6. It's 6 units away. It has a distance of 6, okay? But that changes when you have a number that's like all the way over here at -89, somewhere all the way in the far left somewhere. And then if you have like 103 on the far right side, you need to find that distance. So we could actually, there's a very nice formula that allows us to calculate this, to find that distance. And this pretty much sums it all up. It is the absolute value. So let's, for instance, we're going to say AB is equal to, and we're going to do absolute value bars. Hopefully you remember that. It's 2 vertical lines that go all the way pretty much to the top and bottom of your lines. It's the absolute value of the difference means subtraction, between the coordinates. So if I'm looking at A, the coordinate for A is -2. The coordinate for B is 4. And just like I said earlier, it's the difference, so we put a minus sign here. And we could calculate this. -2 minus 4 is a -6. And then we could say the absolute value of -6 is a +6. And this is the important part, that we turn all absolute values into their positives, because there's no such thing as a negative distance. You cannot go -6 units or 6 blocks or what have you when it comes to distance, okay? And it also works the other way around. If I went from B to A, it would still work out. So if I said BA and find that distance, we would say the absolute value of 4 and -2, and it's a difference, so we put a minus sign between it. Sorry for the small print. Let's zoom in a little bit. We have 2 negatives in a row, so we add those, or we put pluses, we turn them into positives. Then we have 4 plus 2, which is 6. The absolute value of 6 is then equal to 6. And we get the same distance. So you can see it works both ways. And we didn't do it wrong. We did it absolutely right. We counted. We did it absolute value of AB, absolute value of BA. We're good. Okay? So that's our distance formula. Our next definition that we do need to know is the Pythagorean theorem. Now, we're only going to pretty much define it, what it is, and how we use it. But it's going to be more so important for the distance formula. So the Pythagorean theorem, hopefully you've seen this before, you've heard of it, is a very, very convenient formula. We're going to use this a ton in geometry. And it is probably one of the most used formulas that you'll ever hear. It's one of the most common ones. A squared plus B squared is equal to C squared. And we use this almost exclusively for right triangles. Sometimes we use it in non-right triangles, but that's a different story with law of cosines, law of sines, all that stuff. But I digress. Here we're going to be working with a right triangle. And you know something is right if it has this square in one of the angles. This means it is a right triangle, or this is a 90-degree angle. Let's say a 90-degree angle. It's 90 degrees, okay? Now, another important feature about this is when you have a right triangle, there's clear sides to it. There are 3 sides in a triangle. We have legs to them. So we could call this leg 1. We could call this bottom one leg 2. And this is the more important one. The one that's directly across the right angle or the 90-degree angle is called the hypotenuse. And typically, always, this is the longest side. The hypotenuse is always the longest side. Okay? So in this particular case, we have a Pythagorean theorem here. And notice we have 3 variables. This pertains to the 3 sides. This could be leg 1. This could be leg 2. And the c value, the c squared, or the value that's by itself, you notice that there's an equal sign here, the one that's by itself, is always the hypotenuse. Okay, that is very, very important feature. Okay? And that's pretty much what we need to know about the Pythagorean theorem. Hopefully this is familiar. You've seen this before. You've heard of it. And we're going to be using that. Okay? And I'm going to make this a little bit of an indentation because it is very much related to the Pythagorean theorem, is the distance formula. And the distance formula, okay, relating this to the distance equation here, the distance equation up above worked in one direction. The distance formula that we're about to talk about is going to be working in 2 directions. So instead of just going left and right, we're going to be going on a diagonal of some sort. Oop. So if I wanted to find the distance from, let's say, A in the bottom left to B to the top right, we use the distance formula. We're going to be making a right triangle. And think of it like blocks in Chicago. You would not be going straight through because you can't go through houses. There are houses in the way. So most of the time, you'll just be making straight lines down the street and upwards, something like that. And you'll make a right triangle. And that's how we use this distance formula. So you can erase this. This is not really important. I should have put that in pink. I'm sorry. But the distance formula helps us calculate that distance from one point to another in two dimensions. So, simply put, it is the distance between 2 coordinates. 2 coordinates in the xy plane. So just like I mentioned, just like I diagrammed earlier, that's how you're in the xy plane, you're working with left, right, up, and down. And here's your formula. D is equal to, and this is a very long formula, it's a big square root symbol, and we're going to put 2 groups. Okay? In between those 2 groups, we're going to put a plus sign. And then on the outsides of both groups, we're going to put a squared. Now, right away, let's not get into it. On the insides of both of these groups, we're going to put an x2 minus x1 and a y2 minus y1. Okay? Now, this is what I want you to kind of realize. I'm going to put this in pink. This Pythagorean theorem, I'm going to rewrite it so that it says c squared is equal to a squared plus b squared. Now, if you wanted to get c completely by itself, you could square root both sides. And squares and square roots cancel out. So our equation would then read c is equal to the square root of a squared plus b squared. And looking at this, comparing these 2 particular problems, they actually look very, very similar to each other. And they are. Because whatever this x2 minus x1 is becomes our a. Whatever this y2 minus y1 becomes our b value. And then you square them, just like you do. and then you take the square root of them. So they are very, very similar to each other. And if you have trouble remembering this distance formula, it might be easier to remember the Pythagorean theorem and work backwards. And that's what I'm trying to get at, okay? So this is your distance formula. You're going to use this to calculate the distance between particular points in the xy plane. We could calculate what that distance is. Okay, we'll do some examples in our practice packet, but you'll see what I mean when it comes up. So that's our distance formula. The last definition we need to know is a midpoint. Midpoint. And it is exactly what it sounds like. It is the middle point, but it is not anywhere in the middle. It has a very specific value. Midpoint is a point that divides a segment into two. And here is our symbol, hopefully you remember this, congruent segments. So you take one segment, you cut it in half, into two equal halves, I should say. And there's a nice formula for it. For instance, I'm going to draw a quick diagram here. I'm going to say let's use different letters. Let's use J and K. And then here, I'm going to put M. I'm also going to put little dash marks here. So that means M is directly in the middle. M is the midpoint. You could also say, using this definition, JM is also equal to MK because it is directly in the middle. That M is directly in the middle. With that said, using this in the coordinate plane, we need to use points. We need to use XY points. So we use this, the midpoint formula. Sorry, I should have given this another a little bit of extra space. It's a point that divides into two segments, and there's a midpoint formula. I guess we could do it right below it. Here's the midpoint formula. Midpoint formula, just so it doesn't mess up your notes, just put it right underneath it. It is used when we're given 2 points. The midpoint, let's say xy, x2, y2, or x1, y1, x2, y2. x1, y1. Ugh, I don't like this. Let's write this. Let's start this over. Given 2 points, x1, y1, and x2, y2. Okay? Use this formula. And we're going to say M for the midpoint is equal to, in parentheses, x1 plus x2 all over 2, y1 plus y2 all over 2. And notice it's going to shoot out. It looks like it's an ordered pair. It looks like it's going to be some kind of x and a y, x comma y, just like it's a coordinate. And that's what it's supposed to be. Okay? It's always supposed to be an x value and a y value. So M is then equal to whatever this is, or as a result. So actually, you don't need this here. We're done. Okay? Take a look at the practice problems, the practice video, and I'll see you in the next one. Bye.